Ever wonder how a rocket is launched? Well, in this video, we'll show what happens before and during liftoff. First, let's take a look at the rocket on the launch pad. This rocket has a net force of 0. How do we know this? The rocket has two forces acting upon it, the gravitational force and normal force. As you can see from the diagram, there's a gravitational force pushing down on the rocket at a force of 9.8 meters per second squared. There's a force which is counteracting the gravitational force called normal. This force is pushing upwards. Since the two forces are equal to each other, they cancel each other out, thus resulting in no net force. This means that there is a balanced force, the rocket remains at rest. This relates to Newton's first law, which states if an object is at rest or at constant velocity, it will remain at rest or constant velocity unless an external force is applied. Since there is no external force applied to the rocket, it remains at rest.
Now let's look at the rocket when it's about to accelerate. A rocket accelerates due to fuel. Burning of the fuel helps overcome the force of gravity. In this case, the net force direction is upwards, so the acceleration is also upwards. This aspect of the rocket relates to Newton's second law, which states that an object will accelerate in the direction of the net force. The acceleration is directly proportional to the magnitude of the net force and inversely proportional to the mass. This can be represented by the equation F is equal to ma, in which net force is equal to mass times acceleration. From this visual, we can see that the rocket accelerates due to the burning of fuel, resulting in a decrease in mass. This can be represented in a free body diagram, which shows that the thrust force is greater than the gravitational force, resulting in the acceleration of the rocket. This also means that the forces are unbalanced and that there is a net force present. This flowchart shows a brief summary of what we have just explained. Scientists look at three factors: force, mass, and acceleration when designing a rocket. They also take into account the different forces that are interacting with the rocket, such as friction, which takes the form of air resistance. All of this information can be used to determine how much fuel is required for the applied force, thrust, to be greater than the other forces acting on the rocket. This will result in the acceleration of the rocket.
What causes a rocket to lift off? Well, let's first determine the action and reaction forces acting on the rocket. In this case, the action force is the rocket engines burning rocket fuel, creating tremendous pressure which causes the expanding hot gases to accelerate from the bottom of the rocket. The reaction force is the expanding hot gases pushing up from within the chambers of the rocket, causing the rocket to accelerate up. The action and reaction forces can be explained by using Newton's third law, which states for every action there is an equal and opposite reaction. This diagram gives a brief overview of the action and reaction forces. Furthermore, the rocket's engines build up a tremendous amount of pressure that causes the expansion of these hot gases. This tremendous pressure is called thrust.
Newton's third law can explain the generation of thrust by a rocket's engine. Thrust is a force which moves an object through the air, in this case the rocket. It is usually generated by a propulsion system, which is a machine that produces thrust to push the object forward. The main purpose of thrust is to help overcome drag which is present in the air and the weight of the rocket. Thrust is a vector quantity and is generated in the opposite direction of the accelerated gas. Thrust of a force is represented by change in momentum over change in time. Momentum is a quantity of motion of a moving body and is measured by using the product of mass and velocity. It is represented by the formula momentum is equal to mass times velocity. Therefore, the formula of thrust is momentum 2 minus momentum 1 divided by the elapsed time. This formula is similar to the formula in finding the slope of a line.
Now you know the forces on a rocket at rest and how a rocket lifts off. Now we're off to go on a rocket. Up, up, and away we go!
Created using Powtoon.